Hey there. So in this video, what I want to do is show position data and actually get velocity out of it. So how do we do that? Well, first, let's take a look at the data we already made into a graph from the Falcon Heavy test launch. So in the Falcon Heavy test launch, we tracked the altitude of the booster and its change over time, and we saw that this is basically a graph of position. We just are calling it altitude in this case, and we saw that its position was moving away, 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 and then back down towards the origin, so back down towards the ground. But what you can also notice is that it wasn't moving equally at all times, right? So at some points its position was changing more, and at some points its position was changing less. So we can take some information out of this just by calculating the slope. So what's slope? Slope is change. Slope is rise over run, or change in the vertical over change in the horizontal. So we could perhaps draw, here's the vertical change if we're going from this point, we're looking at the slope between these 2 points. Here's the change in vertical and here's the change in horizontal. And you might be familiar with, well, we could try to estimate what these are by using the graph. So let's say that's 22-ish, and that is 5-ish, so that'd be about a change of 17 in the vertical, and this is 1 and 2, that's a change of 1. But what we also know here is that we have the original data points. So I highlighted the points here, and you can see this matches up to this data right here. So time 1, altitude 5. And this matches up to the data right here. Time 2, altitude 23. So there we can do the slope by saying how much did it change in the vertical versus how much did it change in the horizontal. So slope here for that particular segment is going to be the change in vertical, which is 23 minus 5, divided by the change in the horizontal, which is 2 minus 1. And that works out to 18. 18 watts. So what is this telling us? Well, this is telling us that the change in altitude was 18 kilometers in 1 minute. And that's a rate, right? That is actually a speed, but we happen to know that it was going up. So we could write it as a vector with an upwards arrow, or we could say 18 kilometers a minute up, right? Let's use the slope to figure out what is the velocity at in that segment of the trip. And we can do that with any set of points that we want to. And then the other thing that we should point out is that you also are going to want to do this in the other direction. So velocity is a vector, and velocity can therefore be positive or negative depending on the direction. So let's try it between, say, these 2 points. Here's 1 point, here's another point. What was the velocity there? So let's calculate a slope. We've got the vertical change, and we've got the horizontal change. So what was the vertical change? Well, let's actually go back to the numbers. This was at time 3.5 minutes. So that's over here. Minutes. It was 33 kilometers altitude, and then down here, this is 5 minutes. So 5 minutes, it was 13 kilometers altitude, right? So what was the change in the vertical? Well, that was actually 13 minus 33. So we go with the final one minus the original one, and we divide the same thing with the time 5 minus 3.5. So 13 minus 33 is actually minus 20. And 5 minus 3.5 is 1.5. So if we put that into a calculator, what you'll see is 20 divided by 1.5 is 13.3, but it's negative, right? It's negative. So this equals 13.3. 13.3. Sorry, my pen's not working great. Kilometers per minute. Kilometers per minute. But it's negative, right? We've got to put a negative sign in there. Why? Because it was going down. So we're going to actually want to represent this with a vector, an arrow going down that says 13.3 kilometers per minute. And so that's how we can use position over time data to get ourselves velocity. And remember, it can be negative. If it's going down or it's going away from the positive direction, it's going to be negative, and it's going to be a vector. All right, see you in the next video.